An absolute value function algebraically looks something like this, where no matter what you input for x, your y always spits out a positive value. So if x equals 1, y would equal 1. If x equals 2, y would equal 2. But if x equals -3, y would equal 3. If x equals -4, y would equal 4. Graphically, these have to be graphed as piecewise functions. So let's take a look at this example over here. Aaron is describing the boundary line of the absolute value function graphed below. His description should be, the boundary line is x equals, well, let's take a look at some of the parts of a piecewise function. You have two linear functions that make up any piecewise function, as you can see over here. You have a vertex in a piecewise function, which is just the minimum of the function, its very bottom value. You have some sort of a boundary line. The boundary line of a piecewise function is where does that function change? At what point, x value, does that piecewise function change, or that absolute value function change? And absolute value functions are always continuous functions. They do not have a gap. They don't jump in y values between the different types of functions that are involved. So we can see we have a decreasing linear function from x equals -infinity down to -2 in this one, and then at -2 we have an increasing linear function. Our boundary line is going to be at the location where our functions change in this absolute value function, which goes through the point -2 on the x-axis. So our boundary line is x equals -2.